Okay, so in this video we're going to be taking a look at completing, hopefully from start to finish, an entire cooperative puzzle game that's going to feature split screen mechanics and also take advantage of all the topics that we've learned thus far. So let's go ahead and get started. First thing we're going to do is we're going to go ahead and build our scene out. This is just going to be primarily done using just very, very basic shapes, so nothing too fancy here. So what I'm going to do is I'm going to create a cube. And so this cube is just going to kind of represent what an individual space in this game is going to look like. And since we're still kind of describing what this game is actually going to be, we're going to kind of be constructing a scene so that that's understood. So hopefully by the time that we're done kind of putting all these pieces in place, it'll be understood what type of game it is that we're making. So let me go ahead and move this cube so that it is actually visible by our main camera, something like that. So the idea of this game is that we're going to have several of these cubes, and these cubes are going to ultimately be forming almost like a three-dimensional grid, but the game is going to be played two-dimensionally. And so you can imagine that each one of these individual cubes represents a single space upon which the player is capable of walking. And our players are simply going to just end up being these spheres, so nothing too fancy. They'll be able to move around, and as they're walking, they'll just kind of snap to these grid spaces. So the game will be played pretty much on a grid, and all of the actual gameplay will take place two-dimensionally, so there won't be any moving up or down or anything like that. At least that's not what we have planned, but maybe if you plan on taking this project further, you'll end up implementing something like that. Okay, so hopefully it's kind of understood what it is that we're sort of going for. Just a basic game in which players are these spheres and move around. We haven't really talked about what their objectives are, or what their goals are, but hopefully this kind of sets the pace and provides some understanding of what the game's going to end up looking like. Cool. So with these pieces in place, I can just go ahead and get rid of these cubes because I'm actually just going to be creating one cube and making a prefab out of it and then instantiating that cube again and again. So each one of these grid spaces is really only useful to the player in that they can see it. But what we're going to do is we're actually going to make this a little bit more useful. We want it so that the player actually knows that they're standing on top of it. We also want the cube to be able to perhaps know that a player is standing on top of it. So what we're going to do is we're going to be creating a second cube. So here I'm just going to make a cube. And I'm going to take that cube and I'm going to raise it just above that original cube. And then I'm going to scale it down to 0.5 on each one of these axes. I'm going to go ahead and set its box collider to be a trigger because I don't actually want things to collide with it. Actually, that is to run and be repelled. We actually want to be able to detect that things are touching it, but nothing beyond that. I'm also going to be disabling the mesh render on this object simply because I only want it to symbolically represent when a player has entered that space. So there's no need for it to be visible. I'm going to go ahead and just name this. So this will just be grid space trigger. And then I'm going to go ahead and take the actual cube itself and also just name that grid space. And I'm going to drag and drop the grid space trigger onto the grid space so that now they are the grid actual trigger is bound to the grid space. Cool. I'm going to go ahead and create a special tag for my triggers just so that I know when I've made contact with them. So I'm just going to click add tag, and I'm going to be, some of these tags are left over from a pre-existing project, so I'll just go ahead and delete them. So delete. And I'm just going to go ahead and add a new tag, and this one is just going to be grid space or grid square. Grid space is what I've been calling them. So there we go. Cool, so let me go back to my grid space trigger, and I'm going to make sure that it's tagged as a grid space. So the idea is that I want to know when I am occupying a valid grid space. And with that, I'm going to go ahead and take my grid space and drag and drop it into my project view, so that now I have this prefab, and I can just drag and drop these prefabs everywhere. But that's the most important thing, is that as I go and I duplicate these cubes everywhere, these grid spaces, that they'll all be prefab linked. So if I make modifications to them, those modifications will propagate across all instances of this prefab. So now I can just kind of start building out a basic level. And each one of these now represents an individual grid space, and any changes that I make to one of them is made to all of them. Cool. So I want this game to be played two-dimensionally, but I also want it to look kind of cool and take advantage of the three-dimensionality and the shadows and all sorts of other kinds of cool stuff. Shadows if you're using Unity 5. And so my scene view right now looks more interesting than my play view does right here. So what I'm going to do is I'm actually going to make it so that my play view camera is going to be basically looking exactly how my scene view camera is. The way that I'm going to do that is with a special, just a little shortcut. I'm going to click on main camera, and I'm going to click game object, and I'm going to click align view to selected. Or actually rather, whoopsie, no. I'm going to go ahead and redo that. So let me go ahead and get this into position. I'm going to click on game object. I'm going to click align with view. There we go. Yeah, that's a little bit better. Yeah, game object, the game object dropdown has like all sorts of like other different things that you can do to kind of set up alignment. And this is just like it's a real quick like tool. I could have just like manipulated the camera however I wanted to kind of get this sort of like look, but this was just faster to do. And so you can see that kind of like that looks better. The game looks like it's played a bit more three-dimensionally, and so it looks a little bit more modern. Cool. I'm going to go ahead and create a C# script, and this is just going to be my player controller. Eventually there will be more than one player. So go ahead and double click on that to launch it, and here's my player controller class. All right, so I'm just going to go ahead and implement some basic movement. So I'm just going to say if input dot get key down. I'm just going to look for key code dot up arrow. Then I'm going to elect to move this object. So I'm going to say transform dot translate vector3 dot forward times. Actually, I don't even need to do any sort of multiplication. I'm just going to move this as a complete grid, in one complete grid square. So I'm just going to leave that as is. So save that and minimize this and attach it to my sphere, which I'm actually now going to go and name player. So we'll attach our player controller script like this, and I'll press play. And upon pressing the up arrow, I should move forward an entire grid square. Now, you can see that if I keep on pressing forward, that eventually this will create a problem for us, and that is that, we want to probably create levels that are going to be more expansive than just this, which means that the camera is going to need to do some extra stuff. So what we're going to do is we're going to create a camera dock for our player controller. First thing I'm going to do is I'm going to take my main camera and I'm going to double click on it. Double clicking on an object moves this invisible 3D insertion point in the scene, which means that essentially the next object that I create after double clicking on an object will be created at the exact same position as that object. This is just kind of a handy little tool for keeping track of things. I could do all of this manually, but this is just a bit more convenient. And the whole reason I'm doing this is that if I like the position of the camera right now, and I always want the position of the camera to kind of, be about this far away from the player, then that's, this is the fastest way for me to achieve that. So now what I'm going to do is I'm going to click game object. I'm going to create an empty object. I'm going to rename this empty object to be camera dock, and I'm going to make that a child of the player so that wherever the player goes, the camera dock goes as well. Next, I'm going to create a C# script called camera controller. So we'll go ahead and open up camera controller. So the camera controller is going to be a really simple script that's only going to seek to do one thing and one thing alone, and that is to follow the player around. Now, if you're like saying like, well, I mean, wouldn't it just be easier to just take the main camera and make it a child of the player, so that now wherever I move, the camera will follow the player around? This is actually kind of jarring though. The reason why this is jarring is that instead of it looking like the player is moving, it looks like the world is moving away from the player. And so what we actually are going to try to implement is a smooth follow, so that the camera actually really is capable of capturing that feeling that the player is moving and not the rest of the world. And it's always tiny little touches like this that make games ultimately feel as polished as they do. So I'm going to unparent the main camera. Cool. And now we're going to go ahead and implement this camera controller. So the camera controller needs to know about one object, maybe two later on, but for now just one. So we're going to make sure that it knows about the camera dock. And on update, I'm going to have it smooth follow over to that camera position. I'm going to implement this using a lerp, which stands for linear interpolation. So linear interpolation is basically where I'm going to be over time moving from one place to another. And this is actually one of the smoother forms of movement that you can implement. So in order to move like that, I'm going to say transform.position equals, and this is where I'm going to do a vector3.lerp, and I'm going to lerp between my current position, so transform.position, and my target position. My target position is my camera dock .transform.position. Next, I need to provide what's called a step. And this is basically how fast or over what period of time you want to achieve this. And so I'm going to base this off of time, delta time, times a speed variable, which I haven't implemented yet, so I'm going to go ahead and do that now. So up at the top, I'm just going to implement public float speed. Cool. So let me go ahead and take my camera, and I'm going to attach this camera controller script, and I'm going to drag and drop the player's camera dock into the camera dock slot, and we'll go ahead and press play. And so we'll go ahead and start to do some movement. So you can see that now when I move, that the camera does this nice and smooth follow. Now, if I'm moving rather quickly, that follow kind of doesn't feel snappy enough, so I can go ahead and improve that by just modifying the speed. And this is just like, where you just kind of play around with it, and eventually, you'll hopefully hit something that you feel comfortable and happy with, and I think I'm pretty good with that. So it's much less jarring now that it's obvious that the player moves, the camera moves to catch up with the player, and therefore all of the relative motion is perceived as you're kind of walking through the world. So that's all as intended. So with that in place, the next thing that we can do is go ahead and just implement what this should look like on the part of the player controller itself. So we're just going to go ahead and implement the other directions. So let me just duplicate all of these different directions and try to do this as quickly as possible. So this will be down, make this left, and make this right, and then go ahead and adjust all of the vector directions. So this will be vector3.back, vector3.left, and vector3.right. And so now our player should be able to move in 4 different directions. So go ahead and save this and run it and just make sure that it's working as we expect it to. And yeah, that looks pretty good. Cool. Okay, so with that in place, let's go ahead and talk about the cooperative nature of this game. So the intention is for this game to actually be completed or played by more than one player. So the idea is that instead of just having one player, we have 2 players. So let's say that I have a second player here. And the idea is that these 2 players are going to have to work together in order to solve some problems. Now, by virtue of implementing 2 different players, I now kind of run into a problem. So when I press play, you can see that the same input is mapped to both of the players, which is problematic. So I need to go ahead and clean this up. So one perhaps obvious solution is to go and create a separate player controller, one for each one of the players, but that's actually not a good way to go about solving any problems because that solution doesn't scale very well. And so what does it mean to have a solution that scales well? A solution that scales well is basically you can apply that same idea over and over again, and it doesn't create a linear amount of work for you. So, or even worse, an exponential amount of work for yourself. So, for example, does it make sense for us to implement one player controller for one player? Yes. Does it make sense for us to implement two player controllers, one for each player if I only have two players? Maybe. But then if you scale that way up and you say, what if I'm making a game for 64 players? Does it make sense for you to create 64 player controllers? Probably not. So when you think about it in those terms, you can usually come to the conclusion pretty quickly that a solution is either, it's either something that scales well or it isn't. So I'm going to, instead of creating a separate character controller, or player controller rather, what I'm going to do is I'm going to solve the problem that these spheres are running into by simply introducing key mapping. And so I essentially want these two spheres to act the same. The only difference is that I want them to take different input. So what I'm going to do is I'm going to go into my player controller. And so here in the player controller, you can see that I'm taking very concrete input from the player, and this is a problem. The reason why this is a problem is that this basically means that every single item that has the player controller script on it will be forced to use these key mappings. And so I don't actually want that. What I'm going to do is I'm going to make those variables. So up at the top of this class, I'm going to create public key code. Key code is indeed a valid variable type. So I'm going to say public key code, and I'm going to just call this up input. And I'll set that by default equal to keycode.upArrow. And then I'm just going to implement this for the other directions. And if you've ever wondered how video games do that, where they allow you to provide your own custom input, this is kind of the start of what that looks like. This isn't exactly how they go about implementing it, but this is kind of in the right direction. So let's do up arrow, down arrow, left arrow, and right arrow. So these will just be my defaults. Now what I'm going to do is, instead of looking for a specific input here, I'm going to map this to my variables. So I'm going to say up input, down input, left input, and right input. So I'm going to rename these. I'm going to make sure that one of these players is actually named player 2 and the other one's name is player 1, just so I can kind of keep track of them a little bit better. So now you can see that on each one of these player controllers, I have these key selections. And so right now they're both mapped to the same key sets. So here's player 2 and here's player 1. What I'm going to do is I'm going to go and modify, I guess, player 1's. It doesn't really matter. I'm going to make leave player 2 so that player 2 uses the arrow keys. And I'm going to change player 1 so that it uses WASD movement, so WASD. So I'm going to map its up input to the W key, and its down input to S, and its left input to A, and its right input to D. And I'll go ahead and press play. So now I have each one of these players that is moving on its own. They're using the same controller, but as you can see, the way that they actually use that controller is quite different, at least as far as input's concerned. Now right now, player 1 has, is this player 1? Yeah, this is player 1. So player one has a sizable advantage in the fact that the camera follows player one, and we don't have any camera that's following player two. So what we're going to do is we're now going to go and implement a split screen so that each one of our players can have its own camera. Okay, so one of the first things that we're going to do is, well, I mean, one of the first things you need to do is kind of define where you want the camera to be kind of split. I'm going to split my camera, I think, I don't know, maybe down the middle makes sense for this kind of game. We'll see. So let me go ahead and grab my first camera, which is bound to... this one's bound to the camera dock for player one. Okay, so this is the player one camera, which means I should name it player one camera. Just so I can keep track. And I'm going to go ahead and duplicate that camera. So then now I have two cameras. So this will be my player two camera. I'll just kind of put them, next to each other in the line here, in the hierarchy. Cool. All right, and then I'm going to bind my player 2 camera to my player 2 camera dock, just so that the appropriate camera is following the appropriate player. Okay, next I'm going to go to player 1's camera. And in my player 1 camera settings, I'm going to be modifying my viewport. And so the way that the viewport works is this actually describes how this camera is going to render to the screen. So you can see that when it says that X on the viewport rect is set to 0, that means that this represents all the way to the left side of the screen. And by saying that it has a width of 1 means that it extends 100% or consists of 100% of the screen real estate. So X being 0 means that X starts here, and width spans 100% of the screen resolution. The same thing goes for Y. Y starts at 0 and then extends for the entire height of the viewing space. So if I were to take and modify this so that instead of my width going out by, let's say, all the way to 1, if I change this to, say, 0.49 or something like that, you can see that what that does is that takes camera 1 and it makes it so that it only extends up to 49% of the actual viewing space. Then if I were to go and grab my player 2 camera and I were to say, instead of X starting at 0, if I said X started at 0.51, in other words, it started at 51% of the screen space, and then carried on to the remaining width of the screen. So that's why this is set to 1. Leaving it at 1 is fine. You can adjust it down if you wanted it to. But now I have 2 cameras, and each one of these cameras is looking at a different player, and implementing split screen for this was actually just that simple. Not a whole lot to it. Cool. So very, very easy to implement. And of course, if you just modify these values, you can either increase or decrease this center line. I went with 49 and 51 just so that there's this really nice, obvious center line that separates these two. If you want that to get tightened up a little bit and close this gap just a little bit, then just feel free to modify those values to your heart's content, whatever makes you happy. I'm going to go ahead and differentiate players 1 and 2 even further by just creating a couple of materials. So I'm going to implement my player 1 material, which I'll simply just make like a blue color perhaps. And just drag and drop that material, and then do the same thing for red. So we'll make a player 2 material, and we'll just make that red. And then drag and drop that. So now I have these 2 players, and each one of these players is very distinguishable now. So the next thing I'm going to do is I'm going to implement a different kind of grid square. So let's say that in this world I've got another square over here. Now let's say this is going to be a special square. So with this square, I'm going to introduce something a little bit different. I'm going to create another 3D object. I'm going to make this a cylinder. And the reason I'm making this a cylinder is because I want this to kind of represent like a button on the floor. So let me just go ahead and scale this down a little bit. It doesn't need to be perfect. So the idea is that I just have this this little cylinder protruding from the floor. And what I'm going to do is I'm going to take that cylinder. I'm going to actually completely remove its collider because I don't want it to be collidable at all. And I don't even care that it's triggerable that much. So I'm just going to remove that component altogether. I want to leave the mesh renderer component. I'm going to make another material just so that it's nice and distinguishable. So I'll just call this my button material. And I'll maybe go and change that to, I don't know, maybe like an orange color or something. And then just attach that there, just so that it's, it's colorful. Cool. So when I'm happy with that, with that cylinder, I'm just going to go ahead and take it and make it a child of this grid space. So I'm just going to click on the grid space in the 3D view just so I know which one it was. It apparently is called grid space 9. So I'm going to drag and drop that cylinder so that it is a child of grid space 9, so that wherever I move the grid space, the switch goes with it. I'm actually going to rename this switch to just be like button or something like that. Or better yet, something like trigger button. I don't know. Naming could be better, but oh well. And then I'm going to go ahead and make a prefab out of this. I'm going to give it a better name. So this is just, we'll just call this my trigger button space. Maybe call it the trigger button grid space. Maybe that's getting a little bit long. I don't know. We could argue all day as to what this thing should be called, but at the end of the day, it doesn't matter as long as it makes sense to you. So I'll drag and drop that out here, and now it's very easy for me to just go creating these grid squares wherever I want to. So it's almost like we're making like a level editing tool set, which is kind of cool. So when the player steps on this, I want them to know that they stepped on a particular, I want them to know that they stepped on the square. The square should have some sort of action that is associated with it. Cool. So what we're going to go ahead and do is we're going to modify, we're actually going to create a script that we're going to associate with this trigger so that this trigger knows that the player came in contact with it. So this means we're going to have to do a couple of things. The first is we're going to have to create another C# script. I'm just going to call this my trigger button script or something like that. So trigger button. Now this trigger button script is going to be attached to the trigger of this object. So just make sure that you do that, that you track down the grid space trigger, which is this, just like this empty cube. Drag and drop the trigger button script to it. We're going to be detecting collisions, so we're going to want to attach a rigid body component to this and make sure we disable gravity. And I'll go ahead and open up my trigger button script. Cool. So then I'm just going to go ahead and implement void on trigger enter collider other if other dot game object dot tag equals player, because I care whether or not it was a player that touched this object. So player. Then I need to do something. We don't exactly know what that is yet, but before we even go that far, let's make sure that both of our players are tagged as player. So I'm going to click on player 1, and I'm going to tag it as a player. You don't have to create the player tag. The player tag just comes with every Unity project, so it should just be here. So I'll tag that as player, and this is player as well. So let's talk a bit more about what this game is about and why the cooperative nature of this game is going to be so important. So what we're going to attempt to achieve here is there's going to be problems that only the two players are capable of solving. So for example, let's say that the players want to get to this destination over here. The idea is that they're not going to be capable of doing so individually just because there's this empty gap here. The idea, at least in this game's most basic form, is that switches will be lying around, like this one, that's in such a way that when a player walks over and steps on that switch, that will either enable or disable certain elements of the game board, so that players will be able to, as I said, work cooperatively in order to make, to achieve goals. So the idea is that this space might not be available, so one of the players would navigate over to a button, and upon navigating over to a button, that would then enable that object, which would then enable the other player to now cross over to this other side, which, ostensibly means that this player would now have to go and do something special to allow this player to then step off of this button, because stepping off of that button would then disable that same grid square. So this is how the two players will need to work together in order to achieve their goals. All right, so going back to that script, that trigger button script, what I'm going to do is I'm going to create a public reference, so public game object reference. I'm going to call this my toggled grid space. So then I have this toggled grid space. I need to go ahead and associate it. So let me go ahead and track down my trigger right here. And once I have the trigger and I select that grid space trigger, I now need to drag and drop what space I want to associate. So I'm going to grab, this is apparently called grid space 12. I know it's grid space 12 because it's the one that I disabled. And since it's disabled, you can see that it is, it's just like grayed out up here. So I'm going to drag and drop this into the toggled grid space slot. Going back into the trigger button, I'm going to implement a complementary function here that works a lot like on trigger enter. Oops, I need to make that a capital O. Don't know how that happened. So here, instead of just implementing on trigger enter, I'm also going to implement on trigger exit. On trigger exit works exactly like on trigger enter, except the event that it looks for is when something actually leaves this trigger. So in the event that the player walked into it, I'm going to want to take my toggled grid space, and I'm going to call set active. So I'm going to say dot set active, and I'm going to enable it so by setting it to true. And then on trigger exit, I'm going to say toggled grid space dot set active, and I'm going to set this to false. Cool, so let's go ahead and try this out. So I'm going to move this player back over to kind of their starting position. Go ahead and press play, and we'll see how we did. So here's player one. Player one steps on this trigger, and you can see that that enables this grid square. So the idea is that player two would walk over to this this gap and say, oh no, I can't cross, and then player one would step there, and then player two would be able to walk across, and then now player one's going to step over here and be like, oh nope, there's no way I can get across here. So now it's up to player two to go and find some way for player one to cross. And that's the whole idea of this, the whole concept of this game. Cool, so we have a lot of the basics down. The next thing that we need to involve ourselves with is figuring out whether or not a player is capable of making a move. So this is actually pretty involved. Right now I've just been kind of like playing along, I've been assuming that I can't walk off of the grid just like for the sake of, making this kind of like look cool. But obviously my players, they can go wherever they want to. And so since they can go wherever they want to, there's really no point in me having these rules. Just because, well, like, I mean, even though there's a gap here, I mean, players can jump that gap. So we obviously need to do a little bit more rules enforcement. So what we're going to do is we're going to implement a system by which these players are capable of keeping track of their surroundings and knowing whether or not they're able to move in any particular direction. So what I'm going to do is I'm going to double click on player 1, implement this on player 1 first. Okay, so with player 1 selected, I'm going to go ahead and create a game object, and I'm going to make a sphere. I'm going to move this sphere. I'm just going to hold down the control key just so I make sure I move everything, continue to move things on grids. So holding down control or command, I'm going to move forward, and then I'm going to scale this down to 50% radius. So it's already at 0.5. I'm going to set this to 0.25. Oops, that's for its collider. I want its collider to stay the same. I actually want to change its scale to 0.5 on all axes like that. So it's basically like, it's smaller than the actual player itself. Once I'm happy with that, I'm going to duplicate this several times. So I'm going to duplicate. And I'm going to place one of these in front of, one in back, and one on each side of this player. Now eventually none of these will be visible, but what we're going to be using these for is simply to just act as feelers to determine whether or not a player is capable of moving in a particular direction. So for each one of these spheres, I'm going to make sure that I make it a trigger. So each one I'm just going to go make it a trigger. After they're all triggers, I'm going to start naming them. So I'm going to call this one the front feeler. I'm just going to call them feelers because it's kind of what they're doing. They're just going to kind of try to feel out the surroundings and see what's going on. This is the right feeler. This is the back feeler. And this is the left feeler. So left feeler. I'm also going to add a rigid body to each one of these and make sure I disable gravity. So add physics, rigid body, disable gravity, all the way around. Physics, rigid body, disable gravity. Add physics, rigid body, and disable gravity. Cool. So now that I have those in place, I'm going to make all of them children of this player. So I'm going to grab the left feeler, right, back, and front feelers. And I'm going to drag all of those and drop them onto player 1 so that now wherever player 1 moves, all the feelers move with it. Next, I'm going to go into my player controller. And with my player controller, I'm going to create variables for each one of these. So I'm going to create public game object front feeler equals null, public game object back feeler, public game object right feeler, and public game object left feeler. And with those variables written out, I'll go ahead and assign them. So I'll select player 1. And I'll go ahead and drag and drop all of these. So left feeler goes to the left feeler slot. The front feeler goes to front. Right goes to right. And back goes to back. Next, I'm going to go ahead and create I'm going to go ahead and create a C# script. I'm just going to call this my feeler. Just going to open this one up. It's going to be a pretty simple one. I basically want to know whether or not a feeler is currently occupying a valid grid square. So I'm just going to make this public bool that's just called isValid, which will initially be false. And then I'm going to set up void on trigger enter collider other if other.gameObject.tag equals, and we're looking for the tag grid space, I believe. Let me just go ahead and make sure. Yeah, grid space. Cool. So in the event that it's entered, what I'm going to do is do a couple things. One is just to kind of keep track of whether or not like if my system is working. I'm going to do, well, let me just do a couple things. At start, what I'm going to do is I'm just going to say GameObject.getComponent renderer .enabled equals false. Which means that at the start, all of these individual triggers, like these individual feelers, are going to disappear. And then what I'm going to do, this is just for testing purposes, just to kind of help visualize what's going on trigger enter, I'm going to enable the render, so I'm going to say equals true. And I'm going to turn them green. So I'm also going to say GameObject.getComponent renderer material color equals color green. And then on trigger exit, which means that they're no longer occupying a valid grid square, I'm just going to re-enable them. I'm just going to actually disable them. And at that point in time, I'll just go ahead and set the color to white, even though it doesn't really matter because we won't be seeing them anymore. We'll know that we still did a good job at resetting it back to its original state. So I'll go ahead and save this and make sure that we don't have any errors. And it looks like we're good. So I'm going to go ahead and press play. And okay, so we still have to go and attach this script to each one of these feelers. So I'm going to go to to each one of them. So left feeler, and we'll just drag and drop each one of these feeler scripts. So there we go. And there we go. Cool. So now that each one of those feeler scripts is good to go, I'll go ahead and press play. So now you can see that the only two actual spheres that are visible are the ones that contain active, that like basically they're only there if I can move in that direction. So if I go ahead and push down, you can see that it's actually showing me which spaces are active at any given time, which if you ask me, that's pretty cool. Which means then in the future, what we could do is we could take these, and instead of just making them these like spheres, we could actually replace them with these like floating arrows, which would actually be pretty cool, so that it's a bit more easily understood by the player. But yeah, very, very simple system. But still, it's a system that is very, I mean, it works. What it currently doesn't do is that it doesn't take into account the fact that you can still walk off of the map, but that's cool because we're about to fix that. Cool, so next we're gonna go back to our feeler script. And up at the top, or actually no, inside of on trigger enter, I'm going to say is valid equals true. And inside of the on exit, I'm going to say is valid equals false. And what this is going to allow me to do is back in the player controller, it's going to allow me to check to see whether or not these feelers are actually occupying a valid grid square, which means I can move in that direction. So what I'm going to do now is before I make any of these movements, I'm going to check to make sure that that's a valid direction. So here, when I'm moving up, I'm going to first check. So I'm going to say if front feeler dot get component of type feeler dot is valid equals true. If it's true, then I will allow the forward movement. But if it isn't true, then I'm going to completely skip this step. So let me go ahead and just duplicate this. So now if I'm moving down, I'm going to say, okay, well, in the event that my back feeler dot get component is valid, is set to true, then we're good. And I'll go ahead and close this off like this. And in the event that somebody presses the left button, whatever the left input is, I'm now going to be checking the left feeler. And in the event that that direction is indeed valid, then I'll allow for the movement to happen. And the last thing is the right direction. So I'll go ahead and paste that in there as well. And so in the event that the right feeler is valid, then I'll move in that direction. So go ahead and save. And press play. And so now I'm trying to press left and right and I can't move. So now this system is actually not allowing me to move in any direction where there is not a valid grid space. Now what I could do is I could just go and re-implement all of that work onto my second player. But I actually don't know if I feel like doing all that extra work. So I think what I'm going to do is I'm actually just going to delete player 2. I'm going to take player 1 and make it a prefab. And then I'm just going to duplicate player 1. And change player 1's color to red. Make sure its name is set to player 2. I'm going to remap all of its keys. So change these over to all of the different directional, which are, where are you? Where are they? These are all joysticks. Oh, here we go. So change that to up arrow and down arrow. Actually, no, that was left. Oops. Yes, change this to left arrow. And then this was down. And this one is right. Cool. So there's that, and then I'm going to go ahead and need to relink my player 2 camera. So I'm going to take the camera dock for player 2 and then make sure that that gets mapped correctly. So here's player 2 and here's player 2's camera dock. So let me go to player 2 and then drag and drop the camera dock into that slot, and we should be good to go. These should be working now. So the arrow keys are now working for player 2. And eventually, these green spheres might get annoying for you, but for now, they're super valuable when it comes to just kind of understanding what's going on. So now player 2 try as they might, they can't cross this bridge. Player 1 can now step on this trigger, which now enables the bridge. So now player 2 can actually go walking across. And now when player 1 steps off and tries to cross over, they can't, and now these two are separated. So this creates all sorts of conflict that these two players will now need to resolve together. So that pretty much does it for this basic introduction to this game idea. It's completely expandable. You can introduce all sorts of extra conditions. The most interesting things that you can do is introduce a victory condition by which both players need to have achieved some sort of goal in order to be successful. Of course, you'll have to write all the code necessary to detect that. But probably even more interesting than that is implementing different kinds of grid squares. So we've implemented two different grid squares in this case. There's the one grid square, which is just the triggered square, which allows for the triggering on and off of different item types. But there's really the sky's the limit, and what makes these kinds of games interesting is all sorts of different ways that the players can control or not control how they interact with their environment. So introducing different kinds of grid squares and writing the code necessary to enforce the rules that you associate with those grid squares is really where this project takes on new meaning and really starts to get personalized with your own personal preferences. But hopefully this video made a lot of sense, and hopefully you're able to drum up all sorts of inspiration on how to take it further and maybe even transform it into a project that you're proud enough to put into your portfolio.